Faith doesn't know about mesh topology. Her teacher assigned that specific topic in computer networks to tackle it in the class. She has 8 techie friends named Alex, Ella, Catherine, and Nicole. So she hurriedly called them to ask about it.
Hi, Faith. What's up?
Hi guys.
Hi, Frannies! I have an assignment in our IT 111 class, and we are tasked to report a specific computer networks. And I was assigned to tackle about mesh topology. But the problem is, I don't know what and how mesh topology works and its function. Could you all help me?
Oh, I see. So, a mesh network is a network in which devices or nodes are linked together, branching off other devices or nodes. These networks are set up to efficiently route data between devices and clients. They help organizations provide a consistent connection throughout a physical space. This topology is rarely used because of the significant cost and work involved in having network components directly connected to every other component. In a mesh topology, every device is connected to another device by a particular channel. In mesh topology, the protocol used are AHCP or Ad Hoc Configuration Protocols, or DHCP or Dynamic Host Configuration Protocol. There are 2 types of mesh topologies: full mesh and partial mesh. Full mesh topology occurs when every node has a circuit connecting it to every other node in a network. Full mesh is very expensive to implement but yields the greatest amounts of redundancy. So, in the event that one of those nodes fails, network traffic can be directed to any of the other nodes. Full mesh is usually reserved for backbone networks. With partial mesh, some nodes are organized in a full mesh scheme but others are only connected to 1 or 2 in the network. Partial mesh topology is commonly found in peripheral networks connected to a full mesh backbone. It is less expensive to implement and yields less redundancy than full mesh topology.
How does mesh topology functions within a network?
Self-configuration is one of the popular functions that can be programmed into a mesh network. It is the ability to build and configure itself. When each end node is powered on, it listens for its neighbor nodes. If it finds one or more, it issues a request to join the network and gets admitted, provided that it meets admission criteria such as set by security requirements. Another popular mesh network function is self-healing. It refers to the ability of a mesh network to reorganize itself and keep functioning even if one or more end nodes are moved from one location to another, or simply removed from the network. This function of the mesh network is made possible largely because of the redundancy existing in the mesh topology. If a node in a mesh network fails, messages are sent around it via other nodes.
What about its advantages and disadvantages?
Different topologies have different advantages and disadvantages depending on the size, complexity, reliability, and performance of the network. It costly as compared to the opposite network topologies like star, bus, point-to-point topology. Installation is extremely difficult in the mesh. Power requirement is higher as all the nodes will need to refrain active all the time and share the load. It is a complex process. There is a high risk of redundant connections, and each node requires a further utility cost to think about. Moreover, maintenance needs are challenging with a mesh. However, a mesh topology is the most costly and complicated topology because it requires a lot of cables, devices, and management. Also, it is not suitable for large networks because it can create too much overhead and complexity.
But if we look at its pros, mesh topology has a lot of benefits. First, high reliability. Mesh topology is one of the most reliable networks as each device has multiple paths to other devices. In the event of a link or node failure, network traffic can be rerouted to an alternate path. Second, scalability. Mesh networks can easily scalable as new nodes can easily be added or existing nodes can be removed without impacting the rest of the networks. Third, redundancy. Mesh networks provides redundancy as each device is connected to multiple other devices. This eliminates the single point of a failure issues associated with other networks topologies. Fourth, flexibility. Mesh networks are highly flexible as each device can be easily configured as an access point or as a router. This allows us easy configuration of the network to accommodate new devices or changes in the network traffic. The flexibility of the mesh network arises from self-configuration, self-healing, scaling capabilities. These capabilities are implemented in most mesh networks as part of their required network functions.
Oh, I now know what mesh topology is, but I am really curious where we can find it.
A good example of mesh topology in IoT can be seen in smart home systems, where devices like thermostats, security systems, smart appliances, and lighting systems all connect to create a network. In this setup, if one device loses its connection, the network can still operate by routing data through other devices. This scenario exemplifies the self-healing property of a mesh topology, which is crucial in ensuring the reliability of IoT systems. For most industrial applications, reliability is crucial. Depending on the application, corrupted data can result in anything from a disruptive glitch to a devastating failure. In the wireless world, two primary factors determine the signal reliability of an RF link between a radio transmitter and receiver: RF path loss and RF interference. Consider a conversation between two people. Path loss corresponds to how muted the speaker's voice becomes due to distance or obstacles between the parties. Naturally, the listener will have a hard time understanding the speaker if they are too far apart or if they are trying to talk through an obstacle such as a closed door. Interference, on the other hand, corresponds to ambient noise. It will be difficult for the listener to understand the speaker in a noisy environment, whether the noise is caused by loud music or other nearby conversations. Many other factors, including transmitting power, receiving sensitivity of a radio, can also affect the quality of a received radio signal.
A common example of mesh topology is the internet backbone, where various internet service providers are connected to each other via dedicated channels. This topology is also used in military communication systems and aircraft navigation systems.
Wow, information overload. Kidding aside, I have jotted down all the important details about mesh topology. Thanks to my techie friends, I now know what mesh topology is. Bye! Thank you all again and have a good day.